Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge and its name is minimum time to make rope colorful. So basically in this question we are required to make our rope colorful and how we are required to make it colorful. So for the same, let us read the question. So Alice has n balloons arranged on a rope. You are given zero index ring colors, where color I is the color of I's balloon. So basically, this this color is being given to us. So it is given means ABC is being given randomly, means not specific to corresponding to a particular color, means like blue is there, so B would be there. Not like that, but randomly it is being given. So the next thing which is being there is that Alice wants the rope to be colorful. She does not want two consecutive balloons to be on the same color. So she asks Bob for help and Bob can remove some balloons from the rope to make it colorful. You are given zero base index, integer array needed time. Where needed time, I is the time in seconds that Bob needs to remove I balloon from the rope. So basically this array which is being given to us, that is the needed time array. So from corresponding to this needed time array only, we can easily remove these particular balloons. But the thing is that we require minimum time to remove those balloons so that this particular becomes colorful. So basically the thing is that how we get the minimum time is according to this needed time area only. And when we are required to remove the balloon, or basically you can say the color is only at that point when duplicates are being there. So we are required to remove either of them from this particular array. And we are required to remove in that manner so that whatever is minimum out of them, that could be removed. That is AA which is being here, right? So it corresponds to 3 and 4. So what is minimum out of them? That is 3. So we are required to remove 3 from the same. So that's the whole thing which we are required to do. If we go ahead with the next one, as you can see, all are distinct, so that's why nothing to remove. Here, first two are same, means basically duplicate, so minimum out of them is 1, right? So 1 would be there, then again when duplicates are there, so minimum out of them again is 1, right? So we will be adding a 1 plus 1, 2, the 2 would be our answer. So like this only we are required to remove from this particular. Now comes the part that what is the exact thing which we are required to do so that we get our answer in order of n, because here you can see that it's 10 raised to the power 5. So we can't go with an n square solution. We can go for n log n, but still, if we can go ahead with n solution, then why can't we go with the same, right? So that's all. And now comes the part that how we can do this. So we will be traversing this array, right? So while traversing, we will be checking that is the previous one which is same to the present one or not. But would that much condition give us that our answer which is being required? Means basically about comparing. What I'm saying is that if we go ahead with checking the same, means this A, and then check that what is out of the minimum, right? So this is minimum. So we will be simply adding up whatever we get minimum out of the whatever this present things were there. Means array of I, comma, answer, whatever minimum was there. Means something like that. If we do something like that, right? And if we move ahead again and check that, then basically these two were same, right? So we check that what was again the minimum out of area of I and answer. That's not answer. Basically, we are required with both of these. We can't compare with answer. Means we can't compare with what was our answer which was being stored. We are required to compare basically what is minimum. This one or the other one. So that's the thing. which is a nice way we can do the same, right? But now comes the part that how we are required to implement the same. Means let us think that with some more refinement for the same. So for that, let me explain you that how we can more refine this particular solution. So here comes the part. What we can do is we can take one variable current maximum time, one total time. The answer which was basically that was total time only and the current maximum time what we are getting that thing. And why we are taking current max time, not the minimum time? Because the thing is in the total, we basically require that what is minimum means the present time or the time which we had used earlier. So that's why the thing is that we will be requiring with the current maximum time and we will be resetting this current maximum time at that point when both of them are distinct ones. So that's the thing which we will be doing. I'll let you know while coding part. Let us first do by drag run. So at the starting our current maximum time would be 0 and total time would be minimum of what is current minimum time and what is the array, present number at the array, right? So at that moment, we will be checking that what is minimum, right? So R1 or 0. So basically 0 is the minimum, right? So maximum out of all of this would be the current maximum time, that is 1, and the A of I, that is 1, and current maximum time, that was 0, right? So that's why we are having 1 here. So then we next go, then here 0, then total time which is there. So that would be minimum amount of current maximum time and what is we are having, right? So then after that, we will be moving ahead with what is maximum out of the present time which is being there and the current maximum time which we had stored earlier. That was 0. So out of them, 2 is the maximum, right? So like this only we will be moving ahead and at this total time we will be basically whatever maximum out of current maximum time and the present array time is there, we will be adding that up to our total time. So that's the thing which we'll be doing here. So just for example one, when it was straightforward, but when there are multiple duplicates are there, means at the starting there is duplicate, then out of them current maximum time, and then total time at the starting 0, and current maximum time out of 1 and the whatever was there at the previous moment current maximum time that we are taking here. And then when we go to the another one, means a duplicate one, then we check that because at that moment we won't be resetting it, right? So that's why our current maximum time would be the previous one which was stored, right? So one would be here. And at this moment we will be checking that exactly what is the current maximum time or what is the present array of I which is being given to us. So out of them, what is minimum is basically 1 only, right? So that's why and the total time taken, we will be adding a 1. And the current maximum time will become 2 because 2 and 1 out of the maximum is 2, right? So now when these both are different, right? So then we will be resetting our current maximum time to 0. Then 0 would be added to the same. And then 3 will be the current maximum time because maximum out of 0 and 3 is 3, right? So then again both of them are different. So earlier it was 3 current maximum time, but now we have reset it to 0. Then we will be adding 0 and then now we have updated our current maximum time to 4. Then when it was 1, right? So at this moment we are basically our previous one was duplicate. So we are carry forwarding our current maximum time. So this is what we got. Then total time would be 1. Basically minimum out of current maximum time and whatever we are getting here. So that is the same. And then maximum out of current maximum time and this. So that is 4. Right? So at the end we will be getting 1 plus 1, 2 as the answer. And here we will be getting 3 as the answer. So this was all the explanation for this particular question. And after this explanation, you can think that the time complexity for the same is basically order of n. And the space complexity, as we are not storing anything, that is order of 1. So let us go ahead with the coding part for this particular question. So basically in this question, first thing is that we are taking this total time to store our total time, that is our answer and maximum time, which will be being reset when the thing is that our color are not equal. These both of them are distinct, then we will be resetting the time at 0. But in all other case, we will be adding up with whatever minimum we are having the current maximum time and whatever a time we will be having from this, out of them, whatever minimum would be there, because at the end we require the minimum time, right? So that's it. And current maximum time, because of this thing only, we are able to check at this particular point. We is able to figure out with the minimum which we can get, right? And whenever they are distinct, so we are resetting it to 0. So these are three things are making us to get our total time answer. So this was all for this particular question. If you have any doubt, you can comment that down. And please do like and subscribe to my channel. So this was all for today. Thank you.